Hi everyone, let us discuss this example. So in this example, they have defined norm infinity on this x is equal to C0, 1. C0 means set of all continuous functions which are defined on closed interval 0, 1. That means you can consider this function which is continuous, okay, without any break. So this function f is defined on closed interval 0, 1, so we can declare. So it is a member of x. So x is the set of all continuous functions which are defined on closed interval 0, 1. See, norm infinity is defined in this way: supremum of mod f of t belongs to closed interval 0, 1. That means whatever the function we have, okay, so we will have functions like this, continuous functions getting defined on closed interval 0, 1. So we will have functions like this getting, yes, such types of functions we will have. All these are continuous functions and defined on closed interval 0, 1. So the norm infinity is we take mod, okay, so we take mod of that function. So if there is any negative part, when you take mod, you will have the positive part of it, getting, and what will be its maximum value? That will be the mod of that will be the norm f infinity. That means, for example, if you consider function f, so the function f has a maximum value here. So that maximum value, suppose that value is 100, I don't know, but I am considering 100, then norm f infinity is 100. If you consider this function g, okay, and you are finding its norm infinity, so here function has a maximum value, so whatever that maximum value, that is nothing but norm g infinity, getting. So in this way that norm infinity is defined, and we have to prove that yes, it is norm on x. So that means we have to prove that norm infinity satisfies 4 properties. Let us start to prove one by one. See, definition is already mentioned here, so I will not rewrite it, okay. So I'm considering the first condition is norm f infinity should be greater than or equal to 0. So this thing we have to prove. So clearly we can write, clearly let me write here, mod f of t greater than or equal to 0 for all t belongs to closed interval 0, 1, getting. So when you take mod, there is guarantee that you will not have any negative number. So if you take mod here, definitely it will be greater than or equal to 0, and it is true for all t, right? So what will I do? I will take supremum of it. If each of them is greater than or equal to 0, supremum is also 100% greater than or equal to 0. So let me write, implies if you take supremum of mod f of t, right, t belongs to closed interval 0, 1, then also it is greater than or equal to 0, since each of them is greater than or equal to 0. But see, when you take supremum, we get a definition of norm f infinity, right? So that means implies norm f infinity is greater than or equal to 0, and it is true for all f, getting, it is true for all f belongs to x, and this is true for all f belongs to x, okay. So this is true for any function, any continuous function defined on closed interval 0, 1. So therefore we say our norm infinity satisfies the first condition. Let us go for the second condition. The second condition is norm f infinity is equal to 0 if and only if f is equal to 0, okay. This thing we have to prove. So let us start to prove. Okay, so I will consider, see, I will consider f belongs to x and norm f infinity is equal to 0, and finally we have to prove that our f is also 0 function, okay. So let us write the definition here, if and only if its definition is supremum of mod f of t belongs to closed interval 0, 1, that is also equal to 0. Simply I wrote the definition here, but see, supremum is 0, that means each of them must be 0, getting. For example, suppose there is one student in 10th standard, okay, and he appeared for the examination and result is declared, and in each subject he has got some marks. In chemistry, in science he has some marks, in in social science, in languages, in mathematics, and some marks are there, okay. And we say supremum, that means maximum marks, okay. Maximum marks are 0, so that means maximum marks are 0, that means each of them must be 0, since we are considering numbers are non-negative here, okay. There is no negative marking system. Then if you say the maximum marks are 0, okay, then in each subject he has got 0 marks. So the same logic I am applying here. The supremum is 0 and mod is there, so there is no chances of getting negative number, so obviously each of them must be 0. So let me write if and only if mod f of t is equal to 0 for all t belongs to closed interval 0 1. Okay. See, there is no more space to write. Make a screenshot of it. After that we will go further. So let us use that space to solve remaining problem. Okay, if and only if I will write. So you know that mod is 0, that means the whatever inside mod, okay, that should be 0, then only its mod will be 0. So is equal to 0 for all t belongs to closed interval 0 1. What it means? Function gives 0 value for all values of t on closed interval 0 1. So that means function is also 0. Function is also 0 for on, I should mention on close interval 0 1. Getting? So yes, function gives 0 value for all values, okay, of t belongs to close interval 0. That means function should be 0 on the same interval. So we started with norm f infinity is 0 and finally we got f is also 0. Yes, so that's why we can say second condition is satisfied. Okay, so let us go for the third condition. So for third condition, we take we are taking f belongs to x and alpha belongs to r. So you know that for third condition we take one scalar, or you can say one real number. Okay, what we have to prove? We have to prove that norm alpha f infinity is equal to mod alpha norm f infinity. That means that constant should come outside with mod. This thing we have to prove. Let us start. Consider, okay, I am considering norm alpha f infinity is equal to, okay, norm alpha f infinity. So let us follow the definition. So we'll have this is equal to supremum of mod alpha f of t, getting alpha f of t. I'm simply following the definition where t belongs to closed interval 0 1. That means at a place of f we should write alpha f, right? So now this alpha f will operate on t. Alpha is a constant, it will be as it is, only that f will operate on t. So this is equal to, let me write here so you can easily understand, supremum of only that alpha will operate, f will operate, alpha will be as it is, t belongs to closed interval 0 1. Actually there is a product of alpha and f of t. Mod is also there, so we can take separate mod. So this is equal to supremum of, I am taking separate mod alpha mod f of t belongs to closed interval 0 1, right? So mod alpha is a constant. If you take supremum of mod alpha into this one, or if you take mod alpha outside and then you take supremum, we will have the same value. So that's why mod alpha is a constant, I'm taking it outside. So this is equal to mod alpha supremum of mod f of t, right? T belongs to closed interval 0 1, right? So this is equal to mod alpha. See, we have seen this definition where, yes, this is a given definition of norm infinity. So this is equal to norm f infinity. So we started with norm alpha f infinity and we could take that mod alpha outside. So that's why we can say, yes, that third condition is also satisfied. Let us go for the last condition. Just make a screenshot of it. See, now for fourth condition, we require two elements. So I'm taking f and g belongs to x, okay? And we have to prove that norm f plus g infinity less than or equal to norm f infinity plus norm g infinity. That means triangle inequality. Let us start to prove. So we'll start with very basic thing, which obviously we can write. Let me write clearly, okay? Clearly, mod mod f of t plus g of t, okay, is less than or equal to mod f of t plus mod g of t, and this is true for all t belongs to close interval 0 1. This thing obviously we can write when you take separate mod, okay, so value will get increased, and this is true for mod we know, okay. So after that, what will I do? We can clearly write this is less than or equal to supremum of mod f of t belongs to close interval 0 1, and this one will be less than or equal to supremum of mod g of t, getting t belongs to close interval 0 1. Getting the point? See, this inequality we had already got. So we can say this is less than or equal to its supremum. Getting? We say this is less than or equal to its supremum. Obviously, supreme will be larger than this the given number. And for mod g of t, this one is also less than or equal to its supremum. So the common thing we have written here. So this is definition of norm f infinity. So we can write this is equal to norm f infinity, and that is equal to norm g infinity. This thing we have got. So let me write finally, therefore, what can we write? Therefore, mod. Okay, so you can take t common. That means you can write the same thing in this way, mod f plus g of t. Okay, less than or equal to, this inequality we have got norm f infinity plus norm g infinity, and this is true for all t belongs to closed interval 0 1. Getting? This is true for all t. So this, from this one we have got this conclusion. Okay, and this is true for all t. So if this one is less than or equal to this fixed number, these are two fixed numbers, getting? Then 100% we can take its supremum is also less than or equal to this one, getting? So therefore we can write, so therefore supremum of mod f plus g of t, okay, t belongs to close interval 0 1 less than or equal to norm f infinity plus norm g infinity. Okay, so I will give you one example. Suppose we have few numbers 2, 10, 9, 11 or 15 and so on, some numbers we have. So we say each number, what I'm saying, each number of them is less than or equal to 100. Agree with me? Each number is less than or equal to 100. Then we can say their supremum is also less than or equal to 100. What will be their supremum? 15. 15 is also less than or equal to 100. Same logic I applied here. See, mod f plus g of t is less than or equal to this one, and this is true for all t, then their supremum is also less than or equal to same thing. But see, did you notice this is same as, this is definition of what? This is definition of norm f plus g infinity. Since everywhere we have got that f plus g. So this is norm f plus g infinity, and we have proved this is less than or equal to norm f infinity plus norm g infinity. Getting? So this is nothing but triangle inequality. So we proved that yes, our norm infinity satisfies last condition also. So here we write the conclusion. Yes, so therefore norm infinity is a norm on x. Thank you. Bye bye.